What radio? The music you want.
With your host, Keys Dan.
I think with your IQ, you're unarmed and still very dangerous.
RadioWhat.com.
Okay, let's do it.
What's up, party people? It's Keys Dan with the RadioWhat.com, DJLittleRock.com, coming to you live and in living color from the Radio What Studios. And this is another installment of my podcast, What Makes You Famous? I had a thought earlier. I once thought I was the bright sun in the center of your solar system, but now I fear I'm the dark black hole in the center of your galaxy. I'm not sure what that means. I'm not sure what I was feeling at the time, but I thought it was a little bit profound, perhaps. And now it's on tape. So there, you can attribute it to me. Dan thoughts. But I was thinking about the solar system, and I know that my head needs knowledge, thirst for knowledge. And since I don't have a guest on the program today, I'm going to talk a little bit about the solar system. I have had an affinity for the solar system. It's provided us some comfort in our lives, provided me comfort in my life. I'm glad to be here in this solar system. I'm not sure if there's any other solar systems that afford life-sustaining abilities. So here we are, the blue planet, Earth, in the solar system. Let's get into it. It's a brief look at the solar system on what makes you famous. By the way, if you'd like to tell your story on my podcast, What Makes You Famous, give me a call at 501-470-6386. Set up a time. Or you can email info@radiowhat.com. I'd love to hear your story. I want to know what you know. Everyone has a story. Everyone came from somewhere. You came from somewhere. You're important. Well, that was deep. Keys Dan, RadioWhat.com, DJLittleRock.com. Let's get into it. The solar system. What makes you famous? Or what makes you smarter? The solar system. Let's start with a basic overview of the solar system. Our solar system is a planetary system that orbits a star we call the sun, and everything that travels around it. The planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Dozens of moons and millions of asteroids, comets, and meteoroids. The planetary system we call home is located in an outer spiral arm of the vast Milky Way galaxy. It consists of the sun, our star, and everything that orbits around it. This includes the 8 planets and their natural satellites, such as our moon, dwarf planets, and their satellites, as well as asteroids, comets, and countless particles of smaller debris. Most stars host their own planets, so there are likely tens of billions of other solar systems in the Milky Way galaxy alone. Thousands of planetary systems around other stars have been discovered. Let's go a little deeper into our solar system. Here's a definition of a solar system. A solar system is a star and all of the objects that travel around it. Planets, moons, asteroids, comets, and meteoroids. Most stars host their own planets, so there are likely tens of billions of other solar systems in the Milky Way galaxy alone. Solar systems can also have more than one star. These are called binary star systems if there are 2 stars, or multi-star systems if there are 3 or more stars. The solar system we call home is located in an outer spiral arm of the vast Milky Way galaxy. It consists of the sun, our star, and everything that orbits around it. This includes the 8 planets and their natural satellites, such as our moon, dwarf planets and their satellites, as well as asteroids, comets, and countless particles of smaller debris. Let's go through the size and distance. Our solar system extends much farther than the 8 planets that orbit the sun. The solar system also includes the Kuiper Belt that lies past Neptune's orbit. This is a sparsely occupied ring of icy bodies, almost all smaller than the most popular Kuiper Belt object, dwarf planet Pluto. And beyond the fringes of the Kuiper Belt, is the Oort cloud. This giant spherical shell surrounds our solar system. It has never been directly observed, but its existence is predicted based on mathematical models and observations of comets that likely originate there. The Oort cloud is made of icy pieces of space debris, the sizes of mountains and sometimes larger, orbiting our sun as far as 1.6 light years away. This shell of material is thick, extending from 5,000 astronomical units to 100,000 astronomical units. 1 astronomical unit, or AU, is the distance from the sun to the Earth, or about 93 million miles, 150 million kilometers. The Oort cloud is the boundary of the sun's gravitational influence, where orbiting objects can turn around and return closer to our sun. The sun's heliosphere doesn't extend quite as far. The heliosphere is the bubble created by the solar wind, a stream of electricity charged gas blowing outward from the sun in all directions. The boundary, where the solar wind is abruptly slowed by pressure from interstellar gases, is called the termination shock. This edge occurs between 80 to 100 astronomical units. 2 NASA spacecraft launched in 1977 have crossed the termination shock. Voyager 1 in 2004 and Voyager 2 in 2007. But it will be many thousands of years before the 2 Voyagers exit the Oort cloud. Now let's go through the formation of a solar system. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed, possibly due to the shock wave of a nearby exploding star called a supernova. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of material. At the center, gravity pulled more and more material in. Eventually, the pressure in the core was so great that hydrogen atoms began to combine and form helium, releasing a tremendous amount of energy. With that, our sun was born and eventually amassed more than 99% of the available matter. Matter farther out in the disk was also clumping together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough for their gravity to shape them into spheres, becoming planets, dwarf planets, and large moons. In other cases, planets did not form. The asteroid belt is made of bits and pieces of the early solar system that could never quite come together into a planet. Other smaller leftover pieces became asteroids, comets, meteoroids, and small irregular moons. All right, now let's get to the structure of a solar system. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest the sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first 4 planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They're small with solid, rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants, Jupiter and Saturn, and ice giants, Uranus and Neptune. Now let's get into the potential for life. Our solar system is the only place we know of that harbors life. But the farther we explore, the more we find potential for life in other places. Both Jupiter's moon Europa and Saturn's moon Enceladus have global saltwater oceans under thick, icy shells. Now let's go over what moons are in the solar system. There are more than 150 known moons in our solar system, and several more awaiting confirmation of discovery. Of the 8 planets, Mercury and Venus are the only ones with no moons. The giant planets grab the most moons. Jupiter and Saturn have long led our solar system's moon counts. In some ways, the swarms of moons around these worlds resemble mini versions of our solar system. Pluto, smaller than our own moon, has 5 moons in its orbit, including Charon, a moon so large that it makes Pluto wobble. Even tiny asteroids can have moons. In 2017, scientists found asteroid 3122, Florence, had 2 tiny moons. That was just a tiny bit of information about our solar system. I learned a little bit more. How about you? Let's go through some exploration. That's pretty exciting. Human beings have studied our solar system for thousands of years, but it was only in the last few centuries that scientists started to really figure out how things work. The era of robotic exploration, sending uncrewed spacecraft beyond Earth as our eyes and ears, is only a little more than 55 years old. A fleet of space robots is out there right now exploring destinations from the sun to distant planets orbiting far away stars. That's pretty cool. You know, there's some notable explorers that are listed here on this. This is the NASA Science Solar System .nasa.gov website that I'm getting all this information from, and it's pretty cool. I mean, some people don't have enough time to read, but maybe you can listen to my voice in your little ears and learn a little something. We're learning together. There's some notable explorers that you can look up when you find some time. Tracy Drain is a flight systems engineer. The important thing, and the quote from Tracy Drain is, the important thing about being a scientist or an engineer is learning how to think critically, learning how to be creative, learning problem solving, and learning how to learn. Pretty cool, Tracy Drain. And there's a quote from Susie Dodd. She's a project manager. Math is going to be the basis for all the science and engineering that you will have to do in the future. I've heard that a lot. Another notable explorer is Stephen Edberg. He's an astronomer that's retired. Look him up. Sarah Noble. She's a planetary geologist. She has a quote, "Find an internship. I started my NASA career as an intern. It is a great way to get some hands-on experience with research." Very cool, Sarah Noble, planetary geologist. Philip Davis is the website curator and editor of solarsystems.nasa.gov. Ask a lot of questions, be persistent, and never stop exploring your options, is the quote attributed to Phillips Davis. Nancy Roman, she was an astronomer. Mother of Hubble is what her nickname is. If you enjoy puzzles, science or engineering may be the field for you. Thank you, Nancy Roman. She lived from 1925 to 2018, also known as the Mother of Hubble. Michelle Thaler is another notable explorer. She's the Assistant Director of Science for Communications, I'm guessing at NASA. Her quote is, "Being an astronomer is very much about being comfortable with thinking on your feet and coming up with compelling arguments on the fly." Thank you, Michelle Thaler, Assistant Director of Science for Communications. Melissa McGrath, Chief Scientist. Her quote is, "Do what you love and love what you do. It takes hard work. Don't fool yourself into thinking you can be really good at something without being willing to put in long hours to master it." Thank you, Melissa McGrath. Another notable explorer listed on the site is Mamta Patel Nagaraja. She is science communications. You have to find out what you're good at and what you really enjoy doing. Thank you, Mamta Patel Nagaraja. Another notable explorer listed on the site, Konstantin Batygin, Associate Professor of Planetary Science. Science is not something that you just do by yourself in a room because you're trying to solve something for a higher cause. It has to be fun. Thank you, Konstantin Batygin, Associate Professor of Planetary Science. Another notable explorer listed on the site, John M. Grunsfeld, former Associate Administrator. John is a veteran of 5 space shuttle flights and visited Hubble 3 times during these missions. Cool. Another notable explorer listed on the site is Joby Harris. He's a visual strategist. I use art and design as a way to help scientists and engineers communicate. Thank you, Joby Harris. Jim Bridenstine, NASA Administrator. James Frederick Jim Bridenstine was sworn in as NASA's 13th Administrator on April 23rd, 2018. Thank you, Jim Bridenstine. Another notable explorer listed on the website is James Green, NASA Chief Scientist. My job is to be the top advocate for planetary science in the federal government. Thank you, James Green, NASA Chief Scientist. Also listed as a notable explorer on the website is Giada Arney, Research Scientist. By the time I got to college, at some point, I was like, this is cool. Maybe I could do this for my job. A lot of my friends were bouncing around between different majors, but I knew I wanted to do astronomy. Thank you, Giada Arney, Research Scientist. Also listed as a notable explorer, Gerard Kuiper. I recognize that name from the Kuiper Belt. He lived from 1905 to 1973. He was an astronomer. Kuiper studied the planets at one time when they were scarcely of interest to other astronomers. Thank you, Gerard Kuiper. Also listed as a notable explorer, Elizabeth Landau. She's the senior storyteller. I've always been determined to have a career that I believed in that would allow me to learn something new every day. I want to be constantly learning, and I feel really lucky to have always been able to have jobs like that, where every day I am exposed to something new, people, ideas, or ways of doing things. Thank you, Elizabeth Landau, senior storyteller. Another notable explorer listed on the site, Brian Day, education and public outreach lead. Don't get discouraged. A high percentage of proposals that you work on will not be selected for funding. These are only failures if you don't learn anything from them. Hey, words to live by, Brian Day, education and public outreach lead. Andy Shaner, he's the public engagement lead. Pursue the life you want to live, but don't be afraid to try something you never thought you would try or thought you could do. Thank you, Andy Shaner, public engagement lead. Albert Joey Jefferson is a mission operations engineer. The wonderful part of working at JPL is that perfection isn't expected. However, progression is expected. Albert Joey Jefferson, mission operations engineer. Very good. Learned a little bit more about the solar system and some of the explorers that work at NASA. If you want to learn more, head over to the interweb, particularly this site, solarsystem.nasa.gov. Find out more about the solar system. There's a lot of stuff to see out there. A lot of stuff to know. Maybe I just know a little bit of it. And I learned a little bit more. Cool. It's a brief overview. This is my podcast, What Makes You Famous. Maybe this is the What Makes You Smarter portion of the show. It's Keys Dan, RadioWhat.com, DJLittleRock.com. Thank you so much for listening to my program. If you'd like to be a part of it, if you'd like to tell your story on What Makes You Famous, which is my favorite What Makes You Famous episodes, the ones where you tell your story, give me a call, 501-470-6386, or email info@radiowhat.com. And if you need DJ services, hey, I'm not afraid to give a shameless plug, DJLittleRock.com. in the Central Arkansas area or beyond is Keys Dan, RadioWhat.com, DJLittleRock.com. Peace. I'm out of here.
Radio What? The music you want. Hey guys, this is Shelly G with a fast fact. In the 1926 film version of Don Juan, actor John Barrymore set the record for the most kisses ever in a single film. Barrymore embraced Mary Astor and Estelle Taylor 127 times. Do you have a fast fact? Share it with us at Interactive Radio, RadioWhat.com.
Tweet, yo. Follow Radio What on Twitter at Radio What Twit. Tweet, yo.